Today, I have saved the best problem for last. This is a conceptually challenging problem. Let's see. We have two projectiles. I did not want to write this, so I just drew it. We have two projectiles, P1, P2. They are projected with same speeds, but at different angles, 30 degrees, and the other one is projected at 90 degrees. We need to find out and get this. What is the path of the projectile P1 from P2's reference frame? So how do you solve such a problem like that? Well, there are two ways to do it. Most textbooks will give you a mathematical way of solving it and blah blah blah. But I will tell you an easy way to do this. Remember when we did one-dimensional motion and we were in free fall? And we went to the reference frame of free fall? What did I tell you? What I told you is, whenever you are in free fall, you can always assume that gravity is zero. Why? Remember, if you throw two objects, so let's say if you throw one object, let's say you just drop two objects, okay? Two objects, you drop from the same height. If you drop them, after some time, they're gonna be falling together, right? So after some time, if you see this guy has come here, you also see this fellow also has reached there. So with respect to one fellow, the other fellow seems to be not moving at all. Or in other words, vertically, it seems like they're not moving at all in the vertical. It's not that they're not moving at all, it seems they're not accelerating at all. That means we can forget gravity. So in free fall, we have simple rule. In free fall or free fall reference frames, exists. Okay. So we just have now two objects. One object is going to go straight up if we forget gravity, and another object is going to go straight this way. So now it's almost too easy. All we need to do is calculate what is going to be the velocity of particle P1 as seen by particle P2. So let's do that quickly. Let's see. We need to calculate velocity of particle P1 with respect to P2, and we know how to do that. It is just velocity of P1 minus velocity of P2, and let's do this using polar method. Let's use let's use arrow marks and do that. P1 is this way, so that's just going to remain as it is. So I'm going to draw somewhere over here. This angle is 30 degrees. This is V. And P2, well, we're going to flip it because it's a minus sign. That's also V. And look at this angle. The whole angle turns out to be 120 degrees. So we have to now add this to calculate what the relative velocity is. So if you add it and if you use the formula, you will see the final answer, the relative answer, the resultant also turns out to be V. Because 120 degrees, cos 120 is minus half, you substitute and you get that. Therefore, what it seems like so if you were to draw this whole motion from P2's reference frame, so if you go to P2's reference frame, all you would see is that this particle P1 is just moving in a straight line. So it's going in a straight line this way. That's it. And it will be going at an angle of 30 degrees with a speed V. So although they asked us what is the path, we did just more than that. We know the path is going to be a straight line, but we also calculated what angle with respect to the horizontal and at what speed. The speed is going to remain V. So a kick-ass problem, seriously an awesome problem, and for any time who's a first timer and who has no idea of how to use these things, really going to be in big trouble if you don't know how to solve this. But using this concept, it becomes easy.